the next topic that I want to cover, it's still foundational. So eventually I'll get on to new stuff, but I just want to briefly talk about the browser, the web browser. It's important that we have a basic understanding of how the web browser actually works, because at the end of the day, we are going to be writing a React app, and the React app runs inside the browser. So you need to have a basic understanding of the environment in which our React app works. It kind of helps you, I think anyway, to rationalize when certain things go wrong, that you have some sort of understanding as to why they went wrong. Now, there's also an archive with this set of slides. So you just click on this here and it downloads a zip. The archive that comes with this set aren't that important really. You can see, you can certainly flick through them, but you will notice that I include an archive in most of my sections from here on in, and in nearly all cases. What the archive will include is code that I explain in the lecture. And so the idea is you would go back and download the archive and play with the code and make sure you understand it. So I want to walk my way through these slides, and hopefully I'll complete them by today, but I've said that before and got it wrong. So let's see. So the web browser, the first thing we're told here is that it's an event-driven environment. As you interact with a browser, like as in moving the mouse, clicking on things, that interaction is represented internally within the browser as an event. And what you can do is you can associate some JavaScript code that you want to execute when that event occurs. And the JavaScript code can do anything you want it to do. For example, it might make a web API call, or it might try and change what's being displayed on the screen. And that means then that what's being displayed on the screen is actually dynamic. It's changing as the user interacts with it. And that's the basis really of web apps. This slide here and the next couple of slides, I actually quote unquote borrowed from another set of slides, and in the top right there, I'm acknowledging where I got them. There is this guy called Douglas Crockford. He's kind of a superstar really in the world of the web. If you ever Google him on YouTube, you'll get very good presentations made by him. The presentations now would be quite old, but they're still very relevant, and he's usually very entertaining. So I'm just acknowledging there where I got this slide from. So what the slide is describing is how a browser works. And so typically, and just think in terms of the static web now rather than web apps or anything like that. Whenever the browser's URL address bar changes, that's essentially an event. That causes the browser to go into its fetch mode. And the fetch mode is where it sends the request to the particular server that's being mentioned on the URL, sends a request to the server for the HTML page that has been requested by the browser. Eventually, that web page is going to come back. So it's going to be HTML, and there's going to be HTML assets as well. The HTML may have tags in it referring to CSS files, which would cause the browser to get those, and it may include script tags, which would cause the get those. So that's happening as well. But it's the actual HTML that we're interested in for this explanation. So the HTML now has arrived in the browser, and what the browser does is it goes into its parse phase. So it parses the HTML, which is just text, and it creates a structure, a data structure called the DOM, which stands for the Document Object Model. And what the DOM is a network of JavaScript objects. And we know what that is. That's objects inside objects. And the DOM structure is essentially the browser's internal representation of the HTML. And we know HTML is a kind of a nested, we can nest elements inside elements. Each element, as in a paragraph element or a div element or a button element, all the kind of HTML tags that you're familiar with. Each of those is represented as an object in this DOM data structure, or we often refer to them as nodes in the DOM data structure. So it's constructed that. The next thing it does is it goes into its flow phase, where it essentially kind of analyzes this data structure. It navigates down through the DOM, and we know how to navigate the DOM. And it builds another representation of the HTML, which in this slide anyway, he calls the display tree. We don't ever see that or need to worry about it. We definitely are interested in the DOM. And it's the display tree representation that is then taken, and the browser goes into its paint phase, and that's where it actually paints the pixels on the screen. And eventually we have our pixels displaying on the screen. So every time the browser's URL address changes, the browser goes into this sequence of phases. And once it reaches this stage here and it has painted the pixels on the screen, from there on in, provided the browser's URL address bar does not change, from there on in, the browser remains in this cycle of phases that I'm showing you here. So it has just painted the pixels. Now, if an event occurs, and the simplest example would be the user moves the mouse or clicks the mouse, that interaction is modeled as an event, as I said at the outset there. The event is actually represented as a JavaScript object. The browser will take care of creating that JavaScript object. Now, if you happen to have associated some JavaScript code with that event, and I'll show you in a while how you might do that, but supposing that is the case, because let's suppose there was some JavaScript code accompanying the HTML that was sent down to the browser in the previous screen. And in that JavaScript code, we expressed the fact that we wanted a particular function to execute when a particular event occurred. So the association would have been made, if I might go back, the association might have been made back around here. So our JavaScript code runs, and it can do anything it wants to. But if, for example, it modifies the DOM, because the DOM is just a network of JavaScript objects. So we've got JavaScript code here. It can actually navigate that DOM structure as well, and it can make changes to it. Once the DOM structure has been changed, then the browser automatically goes back into its flow phase. So it reanalyzes the DOM, and essentially, if I go back, it comes back to here again. It reanalyzes the DOM and it repaints part of the screen. And that is the essence of a dynamic web page. Event occurs, whatever caused it, either the user or it could be something else. Piece of JavaScript code runs, which is associated with that event. JavaScript code changes the DOM, and anytime the DOM has been modified, then the browser is programmed to reanalyze it, and reflect any changes that have happened to it on the screen. So if we've got a simple web page like this, then the DOM structure, is roughly going to look something like this on the left. Document is a global object that is always present in the browser. And really what hangs from that, so this is my network of JavaScript objects now. What hangs from the document object downwards is dictated by the current web page that is being displayed. But this is just a network of objects, so we can write expressions like document.body that will clearly pick out this object here. And we can drill down into this stuff as well. Now, of course, this stuff is going to change depending on the web page. So how we go from body down to here, turns out that in the body, there are various pointers, and in the rest of the network of nodes, these, we refer to these nodes, there are various pointers, navigation pointers that are created for you by the browser. So for example, the body node will have a first child pointer, and that'll always be pointing at the first sub-element within the body of the HTML, and it'll have the last child. Each individual node here will have a similar first child, last child. There are also references between sibling nodes, and there are even references back up to a node's parent. This is a tree structure, by the way, so a node can only have one parent. So you've got all of these navigation links available to you to allow you to navigate down through the network of nodes. Really, the most you would ever need is the ones that I've just shown you right now. If you've just got these pointers, then you can easily go from here, let's say, down to whatever, this node here, by following the pointers. On this slide here, just by way of example, and this is what comes with the archive now that I've provided you with. Supposing we've got the simple web page on the left, this is how it renders on the left, and the HTML is shown on the right. If we load that page into the browser and open up our developer tools and click on the console tab, the prompt in the console tab, we haven't used it so far, but you may have used it yourself. You can actually type any JavaScript code that you want to at the console prompt. One thing you can do, for example, is to navigate the DOM. And so I'm just showing you some examples of it here. So if I go document.body.firstElementChild, based on what I showed you on the previous screen, that's going to return the fact that this is the first child of the body of the current page that's been displayed. Now it actually shows me this in HTML form because that's more kind of developer friendly. But really what this expression is referring to is, if I go back, it's referring to this node, and a node is just a JavaScript object. But we get a kind of, rather than telling us, look, here's the node and here's all the properties of that node, it's just a slightly nicer experience for the developer to be told, well, that node is actually corresponding to this element within your web page. And these are other examples of expressions. Now, the archive accompanying this set of slides, if I just very briefly pull it into my VS Code. Admittedly, now this is all by way of background information. And again, I'll do my live server trick. There's a couple of web pages in this case, so you need to tell which one do you want to look at. And I want to look at this one. And I open up my developer tools. And as well, I just made life easy for you in this file here. You know, I have some of the commands. If I just grab this one. But this is just object with the dot notation. That's all that's going on there. If I copy that and paste it in. Okay, it's picking out the relevant node within the page on the left. So point of all of this is, as I was saying there, as I was doing it, this is nothing other than using JavaScript's dot notation for navigating a nested network of JavaScript objects. Yeah. So if we can put that kind of code here at the console, we can put it into a JavaScript file. Not that we'll ever be writing code as ugly as that from here on in. Now, in terms of changing the DOM, I said if you amend the DOM in some JavaScript code, then the browser will automatically reflect that. And I'm doing the amending here from the console, but you could just as well have this code in a JavaScript file. And so very briefly, if I step through it, okay, here, all I'm doing here, the document object, by the way, as well as containing references to various nodes within the document structure, it also has functions associated with it that you can invoke. So what this line of code is doing is it's essentially creating a new node. And you've got to tell it what type of node do you want to create. I want to create a button element, if you like. But I'm only creating the element. I'm not attaching it to the DOM. I've created my element. The undefined here means that this method or function just returns undefined. So that's okay. Then I create another node of type a text node, and I want that to be its text. And then I attach the text node to the button. Now, so far, if you were typing these one by one from the console, you would see nothing happening here on the left-hand side, because all I'm doing here is essentially creating a mini little structure, but I haven't changed the overall DOM yet. And it's not until this line here executes. This is where I'm actually amending the DOM itself. So if I type in that line of code, only when I hit return there will you actually see the button popping up on the left-hand side. And you can do this in your own time. So that's a way of proving to yourself that if you change the DOM structure, which I've done here at the end, then the browser will take care of updating what's being displayed. And really, that's what React is all about. Back to this notion of events. So the browser has an event-driven, single-threaded, asynchronous programming environment. So events could be happening, multiple events could be happening in your browser tab. And there is only a single thread, execution thread within a browser, so it can only deal with one event at a time. The asynchronous there is referring to the fact that, you know, the code that you want to run, the JavaScript code that you want to run associated with an event, that won't run immediately necessarily. It'll run sometime in the future. That's because, as I said, you know, there could be multiple events happening, and because the browser only has a single thread, then it can't execute them all kind of concurrently, if you like. I've kind of already alluded to, you know, the different possible types of, or some of the types of events that could occur as the browser is displaying a page. Now, somewhere I found, I think, the full list of, or most of them anyway, so this is a bit over the top really, but you can tell from just the names, and these events have all begin with on something by convention. So you can see there, if as you scan down through them, lots of different occurrences can be modeled as events by the browser. So all eventualities are kind of taken care of. Even, for example, something like if the browser makes a HTTP request to a web API like we had earlier on, and if the web API returns with a some sort of error like server down or whatever, then that's going to be modeled as an event. Or if a web page includes an image tag and the browser requests the image and eventually the response comes back with a 404, then that's represented as modeled as an event, and you might want your page to do something as a result of that. Now, I said you can associate a piece of JavaScript code, a function really, with a particular event, and not only with an event, but you can associate a JavaScript function with an event for a particular DOM node. It's down to that level of granularity. So let's say you want some piece of JavaScript code to run when the user enters text into a particular text box, for example. So and we call the JavaScript code the function that runs an event handler or an event listener. And so you can associate an event listener with a particular DOM node for a particular event. There are two ways that you can do it. You can do it using an imperative programming style or a declarative programming style. Now, what I'm talking about here is very old-fashioned event handling in the browser. We will be doing a lot of this event handling in React, but it'll be in a much more kind of developer-friendly way of doing it. But I'm showing you how it used to be done, I suppose. So here I have a web page, and I've got some function. I've got a function defined inside a script tag. And if you look down here, I've got a text box, and this is how I declaratively associate an event handler with this text box. And in particular, the event handler should be triggered when the text box is changed. So down at the bottom here, I'm showing you what this web page above, how it displays in the browser. So it's a simple piece of text in a text box. And when you type in there, when you hit return, that triggers the hitting of the return, triggers the creation of this on change event by the browser. And because I have told the browser I want to deal with that event for this particular text box, and I'm telling it, I want you to run this function. Now, don't worry too much about the code in the function, but essentially what the function is doing is it's grabbing the text in the text box and it's converting it to uppercase. Right. Again, I wouldn't worry about being able to, we're not going to be writing code like this, but that's essentially what it's doing. You could kind of work it out anyway. And so, you get something like this over here. Now, again, that's included in the archive. So it's not too exciting really, but this is it here. And so I type something, and then when I hit return, boom. So that's just demonstrating, demonstrating the declarative approach towards associating an event handler with a DOM node for a particular event. This is demonstrating the imperative approach. It's awful code, to be quite honest with you, but what am I doing? I have two event handlers here, and initially I associate one of the event handlers, the uppercase event handler, which looks like this one up here. Okay, so I'm associating, I'm associating this event handler initially with my text box, and the uppercase event handler does what you think it does. It changes the text to uppercase. But what I'm doing down here is I'm changing the event handler associated with the particular event for the text box. I'm changing it to be the other function. And so how I would describe this here is I'm using the imperative approach towards associating an event handler with a DOM node. The lowercase one does the opposite, right? It takes the contents of the text box and it converts it to lowercase. And it then says, I'm now going to change the event handler to be the one above. So they just flip between the two of them. But anyway, so that's a kind of a programmatic way of associating an event handler with a DOM node. And the code, as I've said once or twice already, is not very developer friendly. And we don't ever write code like this anymore. We make this association between event and event handler in a declarative way, similar to how I did it on the previous screen. So you won't see this kind of code at all for the rest of this module. Now, come near the end, sorry. Just finish this set of slides if you don't mind. If you have to go, that's no problem. But if I just go back to the previous slide, so I'm using the document. I'm using the document object here to, it has various methods or functions that are automatically available to us. And so we're seeing examples of them here and, down here as well. Yeah, down here as well. So what I'm using there is what's referred to as the DOM API. Every browser comes with this DOM API. API in the general sense now, API is in a kind of a library, not to be confused with web APIs. The original meaning of an API is it's a library that you can use from your code. And so the DOM API is what I'm using here to do my programming. That's built into every browser. That has always been the case from day one, even though they weren't being used. But as you even though it's very simple examples, the DOM API, from a coding point of view, it's very long-winded code that you have to write to do very simple things. But that's what people had to do originally. Then this library called the jQuery library came on the scene, and that essentially made the developers' experience much better. They were still interested in writing event handlers and all of that good stuff, but the sheer volume of code that you had to write was much less than when you were just using the DOM API directly. This jQuery library is essentially a wrapper for the DOM API. DOM API is still being used, but jQuery is taking care of doing all of that for you. And the jQuery's API is a much more developer-friendly API. I've mentioned jQuery before. I'm saying it came out around 2006, and believe me, it was incredibly popular for a long number of years. 10 years, I'd say, or maybe slightly less. But still, but then people started to realize really jQuery code, while we don't write as much as we had to when we were using the DOM API, the code was still spaghetti-like in nature, and it was difficult to maintain. So it solved one problem, but it still had other issues associated with it. And it was from those deficiencies in jQuery that the whole area of single-page app frameworks came into being, React being one of these single-page apps. So we went from jQuery to using single-page app frameworks, and that's where we still are today. But these single-page app frameworks, they are actually using the DOM as well. They're taking care of all that messy DOM manipulation code for us. Right, so that's kind of where we are now. And eventually now I'm in a position, and hopefully you are too, to start looking at one of those single-page app frameworks, in particular React. And that's where I'm going to pick up the story the next day.